So, we are discussing about the electronic transition in diatomic molecules. So, we have seen coarse electronic vibrational structure, coarse I think I can write coarse vibrational structure of electronic spectral line. Okay. So, there we have seen that there is a electronic state, say energy is E double dash in wave number of course, and this another electronic state E energy E dash. So, there will be transition between these two energy level, electronic transition in molecule. So, you will get a spectral lines. Okay. So, transition among the other electronic energy levels. So, you will get spectral lines, electronic spectral lines. Okay. So, now for each electronic spectral lines, now these lines is not basically a one line. So, it forms basically it forms a it consists of a group of spectral lines. Okay. So, that is called basically coarse vibrational structure of these spectral lines, electronic spectral lines. So, what happens, this each electronic spectral line energy levels. So, it contains basically vibrational levels. So, this contains vibrational levels. So, this is itself is a then okay. Okay, so, these are the vibrational levels, their separation is 10 to the power minus 10 to the power 3 centimeter inverse, where this separation is 10 to the power 5 centimeter inverse. So, now following the transition rule, selection rule, del V equal to 0, plus minus 1, plus minus 2, etc. So, the single line now it is basically it is a so you will get a group of lines, okay. So, this called the coarse structure, it is because of vibration of the molecules, and now this each vibrational energy level. Now, again it is a broad, it is a not sharp line, broad line. So, if you see in spectrometer of high resolution, then one can see again it is not a single line, it consists of a branch of lines. So, that basically because of the rotation of the molecule. And so, if I consider just one, any one, if you consider, if you say, if you consider these lines, so these lines, so this is not a single line basically. So, each vibrational energy level now it consists of a of rotational energy level. So, basically this it has rotational energy level, it has rotational energy level. Okay. So, if I consider this one, so here so So, basically it again this vibrational level now it consists of rotational energy level. So, separation of this energy level is 10 to the power minus 1 centimeter inverse. Okay. So, this is really very small separation. Now, this transition, so this one vibrational lines. So, this due to this rotational transition. So, you will get okay. So, here I have shown this just following one del j equal to 0, plus 1, plus 2, plus 3. Okay. So, that is not allowed. So, depending on here like del v equal to all transition possible, but following this way. Okay. But del j equal to 0 and plus minus 1. Okay. Only this one has to follow. So, del j equal to 0. So, from here to here it is possible, from here to plus minus 1, the here to here it is possible. So, here to here it is not possible. So, basically it can be from next level here to here. So, here 1 to 2 and here 1 to 2 and here 2 to 3. So, this is say this is j double dash, this is 0, 1, 2, 3 and here j dash. So, this is 0, 1, 2, 3, 4. Okay. So, one has to follow this selection rule. So, we will discuss about this in details. So, basically each here just one I have shown, this consists of say there are many lines. Okay. So, similarly this one also consists of many lines, but their spacing are really very small, it is 10 to the minus 1 centimeter inverse in that range. Okay. So, this is basically one spectral lines, electronic spectral lines. Now, these electronic spectral lines it has core structure due to vibration of the molecule. So, these are the spectral lines course. So, that we are telling core structure of the electronic spectra. Now, each line again has it consists of few lines. So, that is it is because of the rotation. So, this structure is called the fine structure. So, this fine structure due to rotation of the molecule. Okay. So, ultimately, so this one will is not a single line, it has coarse structure and then it has fine structure. Coarse structure is because of the vibration of the molecule and this fine structure is because of the rotation of the molecule. Okay. So, this we would like to just so fine rotational fine structure, fine rotational structure. Fine rotational structure of electronic vibration spectra, of electronic structure of electronic vibration vibrational, one can write electronic vibrational spectra or spectral lines. Okay. So, ultimately what we will see? We will see basically, so when you will see the spectra, electronic spectra, so we will get basically we will get spectral lines okay. We will get different series of spectral lines. This is one series, okay, and then you will get another series. So, this way you will get another series. Okay. So, you will get series of spectral lines. So, this is basically coarse structure and each spectral line. So, here it is not a single line. So, it is a broad line. Okay. So, you will get this type of. So, these are the fine structure, these are the fine structure, but as a whole overall. So, you will see this kind of electronic So, this kind of electronic spectra of a diatomic molecule you will see, and this is nothing but the electronic spectral lines of a molecule, and in these electronic spectral lines of the molecules you have this kind of coarse structure and as well as fine structure. This coarse structure is due to vibration of the molecule, and this fine structure is due to the rotation of the molecule. So, coarse structure we have discussed how intensity varies, Frank principle, etc. So, let us discuss slightly more about the this fine structure of the rotation due to the rotation of the molecule. So, what is the effect in electronic spectra? So, rotational, so energy due to rotation, okay, that is basically Webb number centimeter inverse. These are in centimeter inverse, these energy levels, rotation energy levels. So, this you know h by 8 pi square I c j plus 1 j plus 1, and if I neglect this distortion due to centrifugal force, centrifugal distortion, this another term d term was there. So, this is basically we are writing b j plus 1, where you remember I is a moment of inertia and b is a rotational constant. B is a rotational constant, right. So, here we have neglected this distortion term, because due to distortion is a very small term. So, here in this case in rotational in electronic spectra, so that contribution is very difficult to detect that contribution. So, that is why one can neglect that one. So, now fine. So, what happens? So, this is the rotational, and now in electronic spectra, what is the energy of the levels, energy levels. So, that if we write E total, so that will have contribution, E electronic plus E vibration plus this. Okay. Now, so due to transition, so energy of the spectral lines, so that is basically del E total. Okay. This we can write del change of this electronic and vibrational energy, electronic and E vibrational. Okay. Then change of this one, change of this rotational one, B j plus 1. Okay. So, this we can write, So, these the energy of the spectral lines. So, now this energy of the spectral lines, this if I write nu bar, so that will be equal to, so here I can write nu bar due to transition between these two vibrational level V dash and V double dash. Okay. So, for that this the, so this term I am writing this, okay, plus now here because of this rotational part. So, that transition one should actually write, that one has to think. So, this just I can write keep it. Okay. So, here we have to set selection rule. So, it is slightly different than the rotation, pure rotation spectra. So, that is so it's slightly different from that in electronic case. So, here, so there we have seen del J equal to you remember. So, here selection rule del J equal to 0 plus minus 1. So, basically there are two kind of selection rule. So, one in case of, one it is telling, so del J equal to plus minus 1, del J equal to plus minus 1, del J is equal to 0 is not allowed. So, in this case, so transition from so plus minus 1. So, one can so when it is this transition is possible, this transition this selection rule is valid. It is telling that states when this transition between states, upper states and lower state, means upper electronic state and lower electronic states. Okay. So, states, rotational states in lower electronic state, then from there transition to the upper rotational state in upper electronic state. Okay. When these states, these two states involve, and if there is no electronic angular momentum of these states. Okay. So, transition between two states. Now, if these two states do not have electronic angular momentum, then in that case this selection rule del J equal to plus minus 1. Okay. So, in this case no electronic angular momentum of the states involved in this transition, no electronic angular momentum of the states involved in this transition. Okay. So, in that case this del J equal to plus minus 1. So, basically you will get P branch and Q branch only. So, that is same as we have seen in case of rotation, rotational spectra. So, P and Q branch only you will see, not Q, P and R branch you will see. Okay. One P, I think one for plus 1 and another for minus 1. Okay. And for other case, second rule, this one first, second rule is del j equal to 0 and plus minus 1, this selection rule will be followed. In that case, so this transition rule will follow when these that states involved in the transition, so they will have electronic angular momentum. So, this will have electronic angular momentum, electronic angular momentum. Okay, electronic angular momentum. Okay. So, in this case you will get P, Q and R bunches. Okay. So, in this selection rule here another things restriction is there, del j equal to 0, but in this case j dash equal to j double dash equal to j dash, okay, but this is not equal to 0. That means j double dash equal to 0. So, from there this transition is not allowed to j dash equal to 0, although del j equal to 0, but this is not allowed. Okay. But other from 1 to 1, from 2 to 2, so only those are allowed. In that case del j equal to 0, but del j double dash equal to j dash is not equal to 0. So, that restriction also one has to put. Okay. So, following this selection rule, so one I can write basically. So, now only things is that whether you will get Q branch or not, that will depend on whether states involved in the transition have electronic angular momentum or not. Okay. So, just here we will write the condition for basically frequency or wave number of the spectral lines. So, there are 3 cases. One I can write, one is I can write that what I will get, I think this. So, these are the spectral lines, this I can write here. So, this I will get, this I will get for I think yes. I think I can write. So, this will be the wavelength, not wavelength, wave number of the spectral lines, okay, and this will come for the electronic vibration transition, this part and this part from rotational transition. So, here del of this I can write basically. So, basically I can write say b dash j dash plus 1 minus b double dash j double dash plus 1. Okay. So, that will be the basically wave number of the spectral lines. Okay. So, for p bunch del j equal to, for p bunch del j equal to minus 1. Okay. So, that means j double dash. So, j double dash basically from lower electronic state there we have considered, and the upper electronic state is j dash. So, j double dash equal to j dash plus 1. Okay. So, this will be the condition for this spectral p for p bunch. So, this selection rule you have considered del j equal to minus 1. So, you will get p bunch. Okay. And one can write this for pre-bunch, this is the wave number of spectral lines equal to this V dash V double dash plus if you replace J double dash equal to J dash plus 1 and then just simplify it. So, you will get basically minus, just I am writing minus, I think B dash minus B double dash, B dash minus B double dash, not minus, plus double dash, J dash plus 1, J dash plus 1, and then plus B dash, I think I should write here, plus B dash minus B double dash, J dash plus 1, I think whole square, J dash minus 1 whole square, yes. So, here J dash equal to 0, 1, 2, 3. Okay. So, this is the pre-bunch, and similarly one can see this 2 R branch. Okay. So, in that case del J equal to plus 1. So, means J dash equal to J double dash plus 1. Okay. So, just if you replace J dash equal to J double dash plus 1 here. So, I think in that case you will get here I can write. So, this I can write now, just I am writing here. So, just R, and I think here it will be just there will be change of sign. I think this both are plus, yes, it will be just plus sign here, and this will put double dash. Yeah, just if you replace it, you will get this, where J double dash equal to 0, 1, 2, 3. Okay. And this third one you will get Q branch, where del J equal to 0, del J equal to 0, right, means J dash equal to J double dash. Okay. But J dash is not equal to 0. Okay. So, if you put that one, then it is the you will get this Q, you will get Q this, and for that I think yeah, B minus, I think here it will be just minus B dash minus B double dash J double dash J double dash J double dash, and then B dash minus B double dash J double dash, yes. Yeah, I think this, I think something I am doing mistake here, just if you this, I think this will be the same, right, because J equal to J double dash. So, it will be J double dash. I think this will be just B double dash, it is B double dash, just one can replace this J equal to J, yeah. Okay. Okay. So, if you take common, so B dash minus B double dash into J dash plus 1. Okay. So, so this part, and then here J, yeah, that I have to replace. So, I will get B dash minus B double dash and J dash plus 1, yes, J dash plus 1, just we have to take common J dash plus 1. So, it will be B minus B double dash. Okay. So, that will be nu q. Okay. So, in this case basically in fine structure, rotational structure, you will get different branches p by. So, it is similar to that pure rotational spectra we have seen. So, there, but there is some slightly difference on the condition on the selection rules, okay. Whether you will get the q bunch or not, that will depend on the situation, and this is only in case of electronic transition. This restriction, this kind of transition rule is valid, whereas in case of pure rotation we have seen this only you will get p bunch and r bunch, q bunch is not possible. But in this case, depending on the molecules, you can get q branch also, and for that these states which are involved for transition should have the electronic angular momentum. Okay. So, these are the fine structure, rotational structure of electronic vibrational spectral lines. Okay. So, I think I will stop here. Thank you.